Hello everyone. In this session, we will see about an implementation of a circular queue using an array. So what is the difference between a linear array and circular array? So in the linear array means here we have seen an diagram. So in the linear array, what happens over here? First element, second element, third, fourth, five, six, seven, eight. It will store linearly. Suppose if I delete the data, then what happens over here? It will delete at the front end. If I insert a data, it will insert at the rear end. So if deletion has happened, what happens over here? The first data will be get deleted, then second data will be get deleted, and third and fourth. But we are unable to reuse the data, reuse the memory location. We are unable to reuse the memory location. That is a drawback which we have in the linear array. To overcome that one, we have gone for circular queue. In the circular queue, what happens over here? The first data, the index called 0 and index is 1, 2, 3, 4, 5, 6, 7. So the first element and the eighth element. Even though the deletion happens and the first element is deleted, then we can reuse the data, reuse the memory location. So I will show example over here. So here we have taken size as a 6. So then what happens over here? So A of 0, A of 1, 2, 3, 4, 5. There are 6 memory space has been allocated. So I'm going to insert a first data. So when there is no data available over here, front is -1 and rear is -1. So then what happens over here? NQ of 10. So I'm going to insert a first data. In the A of 0 position, I have stored a data called 10. So that time the front is 0 and rear is 0, A of 0. Okay, the front and rear, both the values are same. Okay, I'm going to insert second data, NQ of 20. So now what happens over here? Rear has been changed to the A of 1 and then NQ of 30. The third data has been inserted. The rear has been changed. You can observe that the rear is keep on changing. The rear is at first it was here and it was here. Now it is here. Then NQ of 40. Rear is changing and NQ of 50. Rear is changing. So now we'll go for DQ operation. So now in the DQ operation, what happens over here? We will delete the data at the first point. So DQ means what happens over here? Whichever data available in the front will be get deleted. So 10 is deleted and then front has been incremented to the second data. So front is moved to the 20. Then DQ once again. So the front has been updated to the 30. So you can see here. An NQ of 60. Then what happens over here? After 50, we have data, we have memory space, 60 has been stored. An NQ of 70. So in the position called 0, okay, front in the position called A of 0 position, we have stored 70. If it is a linear array, we cannot store the data in the queue. We will tell them as a full. Okay, but since it is circular queue, we can able to fill the empty spaces after deletion. Okay, so then what happens over here? NQ of 80. So the front is something called 2 and rear is 1. Okay, so the data is completely filled. So NQ of 90, it's an overflow. We cannot do it. And DQ 5 times, then what happens over here? So 30 will be deleted, 40 will be deleted, 50, 60, 70. Only 80 will be remaining. So that time front is equal to 1 and rear is equal to 1. If you delete this also becomes front is equal to -1, rear is equal to -1. So this is the operation of a circular queue. So now how do we update the value of an rear? Okay, that's a scenario over here. So we will start to write a program. So as usual, we will define the array size as a n. So let me take n as a 6. N as a 6. So since we have an 6 spaces over here, we will take n as a 6. So at first we will go for an NQ operation. So in the NQ operation, through x variable, we will insert a data. So then once again, what happens over here? If front is -1 and rear is -1. Okay, so then what happens over here? At first, I'm going to change it to the front is 0 and rear is 0. That's A of 0, right? So front is 0 and rear is 0. So I have updated the pointer to front is 0 and rear is 0. And then I will store the data in the queue of rear is equal to X. So what's the queue of rear? The queue is an array. The queue is an array. So the rear value, then rear value is 0. So in the queue of 0, we have stored a data called X. That means that we have stored 10 data over there. So the first case is done. Okay. So then, suppose for example, there is a one case, you just observe over here. When will we call the queue is full? Okay. So just you apply this formula. Rear plus 1 percentage of n is equal to front. Take this formula, rear plus 1. Suppose, for example, if q is full, then what happens over here? The rear value here. The rear value is, what's the rear value here? It is 0, 1, 2, 3, 4, 5. So rear value is 1. Okay, so rear value is 1. So 1 plus 1, 2. 2 percentage of 6. Okay, 2 percentage of 6. So for 2 percentage of 6, take a modulus. Take a modulus. For a 2 percentage of 6, the corresponding, the output value will be equal to the 2. Okay, that means that it is equal to the front. It is equal to the front. Okay, that means that the rear value is 1 over here. The rear value is 1 and front is 2. So the rear value is 1. 1 plus 1 percentage of n. So 2 percentage of 6 is if you take a modulus, the remainder is going to be 2. So that is a front. So if it's equal to front, then that means that Q is already full. So that's what we have done over here. If rear plus 1 percentage of n is equal to front means, then the Q is full. Else, we can store yet data into the next consecutive memory locations. Else, we will update the value. We will update the value of rear is equal to rear plus 1 percentage of n. So then what happens over here? For example, I have one data. I have only one data. So now rear is equal to, I'm going to add in one more data over here. So now what happens over here? Rear is equal to rear plus 1. So what is the rear plus 1? The corresponding real value is 0. 0 means what? 0 plus 1, 1. 1 percentage of 6 is going to be 1. Okay, so now the real value will be equal to 1. So in the queue of 1, I will store a data. I will store a data over there. This is called a circular queue. This is called circular queue and queue operation. So at first simple, if front is minus 1, rear is minus 1, then we will assign the front is 0 and rear is 0, we'll store the data. And then we will check the corresponding Q is equal to full condition. When the Q will be full, when the rear plus 1 percentage of n will be equal to the front value, then that means the Q is full. Else, we will assign the rear is equal to rear plus 1 percentage of n. So, in this case, for example, take this case. Now rear is 2. So now I'm going to enqueue the enqueue 30. So now rear is 2. So sorry, 0, 0, 1. Okay. So 1 plus 1. 2 percentage of 6. For 2 percentage of 6, the value is going to be 2. Okay. That's a rear. That's a new rear value. Rear is equal to rear plus 1 percentage of n. So rear is 1. 1 plus 1 percentage of n, 6. 2 percentage of 6 is going to be 2. That's a rear value. That's a new rear value. So now for in the new rear value, we have stored a data called x. This is operation of an enqueue in the circular queue. Next, we'll see the operation called dequeue. Okay, once again, if front is minus 1, rear is minus 1, it's simple. It's going to be underflow. It's going to be underflow. If front is minus 1 and rear is minus 1, is going to be underflow. Else, if front and rear both are same, then that's only one data available over there. That time the front will be equal to minus 1, rear is equal to minus 1 after deletion. So if we have only one data available over here, after deletion of this data, front is -1, rear is -1. So if front is equal to rear, when both are equal, that means that only one data available over here. After deletion of the data, front and rear both will be equal to -1. So now the third one, the last case, the front will be gets updated. Okay, once you delete the data, the front will be gets updated. So that time we will use a formula called front is equal to front plus 1% of n. That time the front will be shifted to the next index value. So the front will be assigned to the next index value. That's called DQ operation. So simple, front is -1, rear is -1, underflow. If both are equal, then only one data available. Front will be equal to rear is equal to -1. Then in this case, we will take this example. So now here, front is corresponding to 1. We are going to do the operation of DQ. So front is 1, right? So front 1 plus 1, 2. 2% of 6. So for 2% of 6, the remainder is going to be 2. So front is will be equal to 2. We have deleted the data. So front will be gets updated because why the front will be get updated in the deletion always will happen at the front end, and then the insertion will always happen at the rear end. That's why in the insertion NQ we are updating the value of rear. In the deletion, we are updating value of an front. That's an NQ1 DQ operation in the circular queue. So then, if you want to display the data, so simple, we will go for an if both are I is equal to front is -1, rear is -1, then Q is empty. Else, if I is not equal to rear, okay, that means that from the front onwards to be keep on going to until the rear point. Okay, so unless I is not equal to rear, I'll be keep on displaying the data. I'm displaying the data Q of I. Then once Q of I is done, then I'll change the index to next index. So I can we have a formula I plus 1% of n. So it will shift it to the next index. So then once again it will check for I is not equal to rear or not. Then it keep on going. So we will print the whole data which we have available in the circular queue. So these are the operations we have covered in the circular queue. In circular queue, the simple formula we are going to use is going to be I plus 1% of n, or front plus 1% of n, or rear plus 1% of n. If you're going to perform in the insertion, then we will perform rear is equal to rear plus 1% of n. If you're going to if you're going to perform the operation called deletion, then we'll perform the front is equal to front plus 1% of n. If you're going to operation for display, I is equal to I plus 1% of n. This is simple concept. So we have covered an circular queue of an NQ, DQ, and display. So through this circular queue, we have overcome the wastage of memory spaces in which happened in the linear queue. That's the advantage of using a circular queue. Thank you for watching.